Welcome to this video on statistics. In this one we're going to look at probability, which is Unit 4 in your S1 textbooks. With the exam so close to when I'm making this video, what I'm doing here is kind of trying to do all of the unit in one go, covering all the kind of basic steps that you should already know, and maybe just helping a few of you out as we go along. So let's start with a few words. So an experiment, just a repeatable process that gives rise to a number of outcomes. An event is a collection of one or more outcomes, and a sample space is the set of all possible outcomes. And while I believe it goes without say, just a reminder that probability is between 0 and 1. Now that's all I'm going to do in the beginning part there. I'm actually going to jump into Venn diagrams in this next section, as it does cover the majority of the probability section within this scheme of work. The other being tree diagrams. And as a rule of thumb, you will usually, your probability question or questions will be one or the other. Obviously, discrete random variables and normal distribution and so on is also kind of part of that probability. But, when we're talking about more of a straight probability question, that's generally going to be a Venn diagram or a tree diagram. So a Venn diagram is just about being able to visually show your probabilities within their regions. So it's set within a rectangle, and for the ones that you do, you generally will have 2 or 3, I want to say circles, more like ovals, within that Venn diagram. And these are usually labelled, they might be labelled A and B, or the letters to do with what's in the question. And then you usually see this kind of symbol like an E, which is then essentially for everything else. Okay, so everything within the rectangle will total a probability of 1. Okay, and this middle bit here is like an intersection, and what I'm going to do is I'm going to show you ways in which you can find which region you need within a question. But before we jump into that, we need to look at some of the symbols that we're going to use. So if I use A, N, B, this is a intersection B. A, U, B, this is a union B. Okay, these are going to be 2 quite important ones. In general, your intersection is like your multiplied, your union is your adding, but we're going to talk about that in a little bit more detail within this, within the Venn diagram. Now, if I put a P in front of it, then this is the probability. I have to think about the spelling then, of a intersection B, the overlapping part. If I have a little letter N in front of it, which you don't tend to see as much at A level in these questions, but you could see it, that's just the number within a intersection B. So say for example, we had 30 students and let's give these some new letters. So let's say 10 study French, 7 study Spanish, and 3 study both. What that will mean is then that 3 would go, let's call this F for French and S for Spanish. So 3 would study both, that would go in the middle. 10 study French, so I'm left with 7, as within the French circle must total 10. 7 study Spanish, so the total of this circle is going to be 7, so that would give me 4. And here I've got 14, but we've got 30 students, so outside of my circles would be 16. And when I'm looking at these kind of things, if I look at this one, for example, P and let's have F intersection S, that would be 3 out of a possible 30 or 1/10. If I had N of F intersection S, that would just be 3. It's just the number of students that are in that region. Okay, and in this case, that region was obviously this central one here. Now, the problem will often come when we start looking at things like complement. So the complement of A, okay, so this is complement of A, which in layman's terms basically just means not A. So that would mean that, if this was not F, it would be students that didn't study French. Okay, and that could of course be, added on the end of one of these, or on the end of this one, that not. And that's where people tend to have some issues with the Venn diagram. But for me, if you can draw your Venn diagram from the information you're given, then answering the questions is going to be easy. So before we look at learning how to draw the Venn diagram, let's look at one already drawn and how we answer the questions on it. So in this example, you can see we've got a Venn diagram here. B for birds, C for cats, bird circle, cat circle, people who own both, people who own neither. Okay, so obviously I haven't written down the actual full question, just straight in with it here. So let's get straight into it. Probability of B. And what I'm going to do for each of these, I'm just going to show you with a sketch what we're doing. Okay, now when I do these sketches, and obviously I wouldn't for this first one because it's straightforward, but when I do these sketches, I never put the values in because I've already got one main diagram. I'm just doing the sketches for whichever region I need. This is the probability of B, so I shade the whole of B, that's what I want. So the probability of B is my 10 plus 15, okay, because that is the total of B over this total. So 10 plus 15 plus 38 plus 37, which in this case is 100. Okay, but what I'll do is I'll just write them all down so you can see. So 10 plus 15 plus 38 plus 37. So we get 25 over 100, which is 1/4. Okay, nice and easy. And then probability is C. We don't need to draw a diagram for that. So we get our 15 plus 38 over our 100. So 53 over 100, and that doesn't simplify. So there's my first two, very straightforward. Or at least I will hope. So C now is the probability of not B. Okay, so if I think again of my diagram, got my two circles, B and C. Now not B is everything outside of B. Okay, so if you can see, it's this whole shaded area here, everything outside of B. So that's going to be my 38 plus 37 over 100. 100, or 75 over 100, which is 3/4. Of course, since we've already done B, not B can also be 1 minus it, so we could have done the fact that not B is 1 minus the probability of B. 1 minus 1/4, 3/4. So that's our options there. Now that we're getting on to D, we'll bring it in 2 letters. Okay, so again, let's do a sketch. I'll make it a little bit bigger this time. So I got my B and I got my C. Now when I'm doing this is important. You sketch each of these in turn. So the first one is B. So I'm going to sketch or shade B. So the probability of B is there. For the second one, it's C. So I'm going to do C, but I'm going to do it in the opposite direction. Like so. And I do it like that because generally I don't have colours in the exam, just got my pencil. So I use 2 different directions. Now, intersection is where my 2 lines crisscross. So this section here is my intersection. So that's going to be 15. So my probability of B intersection C is 15 over 100, which I can divide by 5, so it gives me 3 over 20. Now, part E, as we can see here, is B union C. Okay, so I approach this in very much the same way as the last question. I draw my quick sketch of my Venn diagram. You can make these quite small, just with your pencil, and then you shade them in turn. B first, and you do that one direction. C second, we do that in the opposite diagonal direction. Okay, and that's purely just so you can see the crisscross. Now, union is everything shaded. Okay, so in this case, the probability of B union C is 10 plus 15 plus 38 over 100, which is 63 over 100. So at this point, I'm going to pause you. When you see, in terms of the question, not hit pause on the video, but when you see N, the intersection, it is where the shading meets. So it's the criss cross, okay, or the overlap shading. When you see union, it is all shading. Okay, now following these, and we're going to do it with these now, but following these simple instructions, you'll be able to work out which region you need in any Venn diagram. So F here, we get the probability of B intersection not C. So again, I just do my quick sketch. Doesn't have to be perfect. Put my B and C in, and then I start with my shading. So B is first, so I shade B. Second here is not C. Okay, so that's outside of C, and I do that in the opposite direction. So outside of C, you can see my shading is as follows. Okay, now we've got intersection, so that's where my shading meets, my 2 shadings meet. So you can see here the crisscross is only in this section. I'll just highlight that there so that you can see it's only in this section of my diagram. So that means that this is 10 over 100, or 1/10. Now do you see how much easier it is with the shading, with the little sketching? Doesn't matter how complicated these are going to get. with this simple fact of shade one, shade the other. If it's an intersection, it's where they meet. If it's a union, it's everything that's shaded. Okay, so, for example, on this one, if I switched it up and then said, since we've already shaded it, this would have the same shading, but because it's union, it would be 10 plus 15 plus 37 over 100. It's basically going to be everything except for the 38. So it would be like 62 over 100 or 31 over 50. Okay, and because the union is everything shaded. So you got this section, this section, this section. Intersection just where they meet, so just that one section. Okay, does that help? I hope so. Let's have a look at G. So G here is probability of B union C, and then it's a not by it. So first, wow, made that a bit big, haven't I? B and C. So shade B, shade C. B union C means that section, that section, that section. Not means now not shaded, so it's just going to be the 37. Okay, so you can do this in two ways. So, just seeing it from the diagram now, we know it's 37 over 100. Alternatively, once you've worked out your B union C, or in our case, we actually did it earlier, then you can just do 1 minus because we've got this not by it. Okay, now I'm going to use not a lot. The official word is complement. Okay, but I'm not going to use that as much. I tend to just use the word not. It reminds me then that that's not what I want. I want the opposite. So either want 1 minus it, or I want the other regions that, is not within this. Okay, so using just that word not just helps reinforce it in my head what I'm trying to find. Now, part H. Again, quick sketch every time, and the first one I want to shade in is not B. So that's everything outside of the circle of B. Okay, and then the second one is C, so we want to shade all of C, which looks like that. We want intersection. Intersection is only where they cross. So again, it's quite straightforward. It's just this little section here. So the probability of not B, or B complement B, intersection C is going to be 38 over 100 or 19 over 50. So hopefully that's made some sense to you. I'm really hopeful that you've already learned this and this is just a refresh, but if you never learned this before, hopefully this will really make a difference for you. Now, obviously you're watching this video and you have actually done all this before, so it should be fine for me to go a little bit quicker. Before I do a few questions, let's add in a couple of extra ones. So what about if we have a given that? Okay, so this one means probability of B probability that B happens given that C has already happened. Okay, I'll write that down. So in the context of this question, it would be, I choose a person at random. What's the probability that they own a bird, given that I know they own a cat? Okay, and that's the given that question. Now, for this one, what happens is, and let's actually start off with a sketch again. So we get B and C. Now, what happens in this one is that C has already happened. So that means that everything else has basically disappeared. Okay, so C's already happened, so we're just down to this little bit. So we know that that's 15 and that's 38. So now the probability that B, given that C happens, is, well, what's the probability of B? 15. What's my total probability here? 53. Okay, because that's my new total, isn't it? So when I see a given that within the Venn diagram, okay, of course you've got formulae that you would have already learned that can help you with this, but if you've got a Venn diagram, you don't need them. The given that part, this end part, that's what your new total's out of. Everything else disappears, just focus on that bit. And then you're looking at the probability of this happening. So it's like, in this case, it's 15 over the 53, sorry. Okay, hopefully that given that kind of makes a bit more sense now. Shall I do another given that? I think I will. So if I add a new one, probability is C given that B union C. So if you think of your full diagram, yeah, B union C, if you remember, is shade B, shade C, and it's everything that's shaded. So in this case, that means I get rid of everything around the outside, and I pop these values in red, but it's 10, 15, and 38. Now, what's the probability of C? So probability of C given that B union C. Well, C is both of these circles, so it's 53, the 15 plus 38, and it's over 63, as that's the total of all three numbers. So hopefully now you've also seen that if you've got a given that question, it actually can be quite easy if it's a Venn diagram. So easy, in fact. How about I give you a question to try yourself? So I would do the sketches, I'll just jump straight in with the answers. So probability of A here is 18 out of 40, which will be 9 over 20. Probability of not B is going to be 19 over 40. Probability of A intersection B is 6 over 40, which is 3 over 20. D, we've got the probability of A union not B. And that's going to give me 25 over 40, which is 5 over 8. E, probability of A. Oh, hang on, I've done this the wrong way around, haven't I? That was E, wasn't it? A union not B. So let's do D next. Probability of A, not A, intersection B. And that gives me 15 out of 40, which is 3 over 8. Now we're on to F. So A union B is everything in the middle, not that is going to be 7. So we go A union B complement, 7 over 40. Now we're on to G, which is the first of the given that ones, isn't it? Probability of A given that B has happened, that's going to be 6 over 21, which we can simplify to 3 over 7. And finally, H, probability of A given not B. And that's going to be 12 over 19. Like 12 over the 19 there. Okay, hopefully you managed to get all of those correct. which is awesome. Next, we need to learn how to draw one. So here's all my information, my total amount, and then we've got a series of sentences that's going to help us create our Venn diagram. And if I look carefully, we've got guitar, piano, or drums, and then we'll have some people who do neither, so we're going to need 3 circles, 1, 2, and 3. So let's draw those first. 1, 2, 3. And if I look through my information, I can see that one person plays all 3, and then we've got this many play 2, and so on. So let's go from there. So we need guitar, piano, and drums. So one person plays all 3, so that goes in the middle, and that's that one done. Now we've got 65 people play the guitar and piano. Guitar and piano is this section here, 65 in total, so that means that's going to be 64, so that these two will add up to 65. And that's that one done. 10 people play piano and drums, so piano and drums is here, and that's 10, so it's going to be 9 in this one. Now 30 people play the guitar and drums, so that's this one, so we got 29 in there. Now we got to go to the all of them, so 15 play piano only. So if they only play the piano, it means it goes in here. 20 play the guitar only, and 35 play the drums only. If it didn't have the word only, then it would mean the whole circle, and it'd be, the total including these values. So the word only is important. So if it's there, it's just that section. If it's not there, then it would be the whole circle. Next, we need to put our rectangle around it. And then what I need to do is add up all of these values. So 35, 20, 15, 9, 29, 64, and 1. And that should total 273. And then taking away that from 275, which is my actual full total, leave me with 102. So 102 people don't play any of these 3 instruments. Next step then is just to use it. Straightforward questions in this one. Find the probability that someone chosen at random plays the piano. So probability that they play the piano is going to be 64 plus 1 plus 9 plus 15. It's that whole circle. And of course it's over 275, as that is the total people. And that's 89 over 275. Now, part 2 is the probability of at least 2. So at least 2 instruments. So that means they could be in this section, or this section. They could also be this one and play all 3. They can't be this one, or this one, because these people just play 1. And they can't be this one because they play none. So at least 2 would be my 64 plus 1 plus 9 plus 29 over 275. And that will give me 103 over 275. Part 3, we'll pop over here on the left, exactly 1. So the people who only play 1 is 20, 15, and 35. And that gives me 70 over 275, which will simplify to 14 over 55 there. And then finally in part 4 is no instruments. So let's just put it as none, and that's going to be 102 over 275. So I think all in all, not very difficult. Okay, if you do get a question like this where you get to draw the Venn diagram from the information, it's going to be worth a few marks, easy marks. And then the probability, finding them once you've got a Venn diagram, as you've seen in the previous question and this one, it's just really easy. Okay, so I'll give you one to do for yourself and then we'll move on to the next little bit. Now, in this question, again, we've got three options. So we need three circles. Okay, don't have to be perfect. And we've got system support, developing software and networking. So let's go system support, developing software and networking. Now, what I want to do is I always want to start with the middle one. So finding that all three options is going to be 4. After that, I want to work on the overlaps between two circles. So let's just cross out as we go along so you guys can follow okay. So let's look here. 40 takes system support and networking. System support and networking, this should be 40. So we've got to have 36. 36 and 4 is 40. 28 take networking and developing software. So again, networking, developing software is here. That's going to be 28. So that'll be 24. And then we have 35 take developing software and networking. That's my last one, so it's got to be 31. As 31 and 4 is 35. And that's done. Now, in this one, I've got 81 take networking. Now, it doesn't say networking only, so it is this whole circle. So I need to take 81 and take these values away to find this one. So that's 64, and taken away from 81 leaves me with 17. Next one, developing software is here. Should add up to 70. So we got 35 and 24 is 59. It's going to add up to 70. So it's going to be 11, isn't it? And then finally, we've got system support is 112. So let's add these up. We get 40, 71. And take that away from 112 leaves me with 41. Next, what I need to do is total all these values up to find out what goes outside. So I want to total everything up. And just as a little kind of hint to save yourself a bit of time, you knew, as I'll cross it off now, 112 took system support. So this whole circle is 112. So that's those 4 values. So 112 plus 11 plus 24 plus 17. And that'll give me 164. And 180 minus that gives me 16. So that's my outside. And then all that's left to do now is to put my rectangle around it. And there we go. Okay, you can put your little E for, well, kind of basically stands for everything, doesn't it? It's that total set. But it's not super important when you are drawing this. You shouldn't get marked down, not for having that. Sometimes you see it inside the rectangle, okay, but this is what's important. If you've got similar things, where they might be the same letter, I would suggest maybe also doing a little bit of a key. In this case, we had system support, we're developing software, so I think S and D was fine. But if we had system support and software, that would be both S. So I would, distinguish. So before I do this, I do a little key just saying what each letter meant. Now, we've got to answer some questions on it. So student choosing at random, find the probability that student takes none of these three. So it's going to be 16. So B, probability of none is 16 over 180. And that will simplify to 4 over 45. Part C, networking only. So networking only means they don't take anything else with it. So it's just the 17. So networking only. That's 17 over 180, which won't simplify. Final part is the harder part, I suppose. Students that want to become a technician take system support and networking. Given that a randomly chosen student wants to become a technician, find the probability that this student takes all three extra options. So it's a given that they want to become a technician, which means they have to have taken system support and networking, which is this section here. Okay, now all three was the 4, so let's do probability that they take all 3 given that they want to be a technician. Sorry, my spelling there's terrible. So that's 4 out of a possible 40 students, or 1/10. Okay, because the given that means it's narrowed it down to a technician, so it means they have to take both of these 2 options, which is 40 students in total. And that is how you can find it from a Venn diagram. And just before we do move on, it's worth pointing out that in this particular question, which is a past paper question, just drawing this Venn diagram was worth 5 marks. Parts B and C were worth a mark each, and part D was worth 2 marks. Total was out of 9. But you can see that this type of question showing up in the exam would be like amazing. But given the way the papers have gone recently, I wouldn't hold my breath. So hopefully you found getting into the basics of the Venn diagrams useful. What I'll move on to next is bringing in the mutually exclusive independent formulas and some more of the notation. And then I'll do a third video then on the tree diagrams, and that should wrap up most of the probabilities, and then I'll try and do a 4th one with just past paper questions. Okay, stay tuned, next video coming soon.